Hello, everyone.
Morning.
Morning.
Good morning, Elizabeth. This is pretty exciting today, isn't it?
It absolutely is our first webinar in Livestorm. Really looking forward to it.
It promises to be a great webinar to kick off this new platform. I'll get this going because I know Stuart and Mark have been working hard on a set of interesting demos to kind of illustrate the power that's at your fingertips, frankly, when it comes to applying FME technology to stream processing. Okay. First off, thanks, Elizabeth, for setting this all up and for the excellent work on the title, Full Stream Ahead, Authoring Workflows for Scalable Stream Processing. So my name is Dale Lutz. I'm one of the two co-founders of Safe Software, and I'm joined today by Stuart and Mark. Stuart, Mark, why don't you introduce yourselves?
Yeah, sure. Thanks, Dale. Morning, everyone. My name's Stuart Harper, and I oversee the cloud group at Safe Software. So FME Cloud, FME Hub, and I also kind of help out on server on the stream processing side.
Thanks, Dale. Thanks, Stuart. I'm Mark Warren. I'm a technical support specialist for FME servers. So if you're on live chat or working with support cases related to FME server, you'll often be working with our team and possibly even myself.
And Elizabeth, you should introduce yourself.
Hi, everyone. I am Elizabeth. I am the webinar moderator here at Safe Software and really excited to be joining you all today.
And I'll probably put Holly on the spot. I don't know if she's in position to come in and say hi, but Holly is in the back ready to answer your questions in the all-new question and answer panel here. So don't be afraid to keep her busy. Holly, are you there? Well, we'll go with the fact that she's there and ready to type to be, I guess, read and not heard. So do keep Holly busy. So basically with this team that's assembled today, just about any question will be fair game, and do keep them busy. So this is our first time using Livestorm, and maybe I should ask Elizabeth, since she's the expert on this, do you want to walk us through this this slide here?
Yeah, absolutely. So you'll see on the bottom left, if you are having any audio issues or video issues, you can click that help button. There's 4 simple steps. And then there's 3 different ways you can interact with us here this morning. We have the chat, which everyone can see anything coming in there for any comments. If you have a question, drop it in the questions tab and upvote any interesting questions that apply to you. And then we have the react button. So you can share your reactions throughout the webinar there with emojis. Yeah, we see people testing it out now. That's great.
Wow, we've never had live reactions before.
Yeah.
Okay, thanks, Elizabeth. So in terms of an agenda today, while we're working our way through the intro, we've got 3 quite interesting demonstrations that are, they're not that complex, but they require you to keep your FME mind, as we like to say, at the forefront. And so the team will be walking you through how these things work. I personally find it extremely gratifying to see how FME technology, invented so many years ago, was able to easily fit into solving these kinds of problems. And then we've got a whole pile of resources. If you like what you saw today, there's going to be a lot that you can do afterwards to kind of dig in more. And of course, we'll be looking at doing some live Q&A, as well as reviewing the questions that went by on the way of the presentation today. So, whoa, we're going to try a poll. Never seen this before inside of Livestorm, so I'm hoping Elizabeth knows what to do. How familiar are all of you with stream processing? So looks like I even get to vote, huh, Elizabeth?
Yeah, you do, if you want to.
Okay. I hope I'm not skewing the vote. Where do we see the results?
So once you vote, you'll be able to see the results come in, or if you click that little eye icon that you'll see, Dale, you can see the results as a team.
I think I hit the poll button down in the bottom third from the right, and it looks like I'm spying on things as they come by.
Yeah, you can also see them there.
Excellent. We got quite a good chunk of voters already.
Yeah.
There's only a very tiny percentage that are actually doing streams in production. And Stuart, from a product management point of view, that kind of matches your impression as well, doesn't it?
Yes, yeah. I think we are a little bit ahead of the curve with this, but that's okay. I think the data sources, kind of the sensors, are going to really come online for many organizations over the coming years.
Yeah, I mean, part of our goal with this is to basically give you the tools so that when this type of a workflow arrives at your organization's doorstep, you know you don't need to be scared, and basically you can make use of the no-code FME environment to solve that kind of problem. So, Elizabeth, should we call that a wrap on the poll?
Yeah, we'll call that a wrap.
So I'll just quickly summarize. It looks like about half of you are here to learn more, and that's fantastic because that's really what Stuart and Mark are excited to do today. About 40+% are familiar with it, but you actually haven't worked with streams yet. And then there's 8% of you that are actually working with streams right now, and that is very exciting. And do let us know if you're using FME, what we can improve, and if you're not using FME, what it might take to get you to use FME. But anyway, we're very excited to have you here as well.
I think at this point we can probably turn off our webcams just to save on some bandwidth, and then we'll carry on with the slides here.
Okay. Then, oh, look at, there's a halo around my head when I talk, so that'll keep me talking nice and loud. So our strength at Safe Software is we like to think that we bring this power of spatial data to your decision making. Very often these stream data flows have a notion of location in them, and being able to, in a no-code way, manipulate and transform data, knowing about the spatial aspect, we think is uniquely valuable and one of the key things we bring to the table. So who are we at Safe? We've been around for more than 28 years solving data challenges, and as you can see, widely used around the world. Particularly proud of the number of active users in our user community. That is community.safe.com. Give that a look sometime if you want to be part of that. Many, many questions and answers flying by every day in there. We really manifest ourselves in 4 different ways, 4 different product lines. FME Desktop is where you build and author the workflows that you're going to either use to solve an ad hoc problem that you just have to do one-off, or maybe you're creating something that's going to run over and over again on the desktop, or you can take that thing that's going to run over and over again and run it on a server, and you can put that workflow up on a server, and then the server will look after kicking it off either a certain time of the day when somebody clicks a web form. There's a way to make web apps in server. In response to a change in the environment, like perhaps a file arrives or a webhook fires. That's what FME Server is all about. Now, FME Cloud is just FME Server with a different business model. We set it up for you on an Amazon machine, and we charge you by the hour. You can turn it off and on. It's a very cost-effective way to get your data processing out there into the cloud. And I guess out of your environment, if you want to do that for security reasons, very popular. And then lastly, we have a couple of mobile apps on mobile, both Android and iOS. We have an augmented reality app we call FME AR, where you can take data that's ground by FME's in world and then display it overlaid in the real world, spatially aware. We also have something we call FME Data Express, which is about giving you a nice client for running those FME server / FME cloud hosted workflows from the convenience of a mobile device, and getting things like spreadsheets, imagery, whatever it is, back on your mobile device, maybe even AR files. We also have a wide range of data types that we support. In streaming workflows, it tends to be tabular data that maybe has some points in it. And if you can see way to the, let's see, where was it? Around 2015, we started to add support for specific Internet of Things types of formats. And Stuart's going to look at some of the modern ones that we support today. Formats is probably wrong. Systems, ways that data comes in streams. But as you can see, we cover off a huge range of data types, and all the tools and techniques you're going to see today actually work pretty much equally as well with any of these data types. So Stuart, maybe with that, I'll hand it over to you, and you can take it from here and walk us through this diagram and all the rest.
Great, yeah, thanks, Dale. So yeah, let's kind of dive into the IoT icon a little bit more that was on the last slide. So when you connect into usually a sensor or some kind of external endpoint with a high volume stream associated with it, you usually don't connect directly to the sensor. The sensor usually connects to a message broker or some kind of service in the cloud, and then your data integration tool will then connect to that message broker. So this diagram represents what the ecosystem looks like, not just what FME supports, but what kind of the entire ecosystem looks like in terms of message brokers and services. And the items colored green are the items that FME support. So you can see we actually have very good coverage. We have Kafka, MQTT, AMQP, JMS, RabbitMQ, and many of the proprietary cloud ones as well, such as PubSub and SQS. So the thing to be really, the takeaway from this slide is FME, if it doesn't connect to the endpoint you want it to connect to, then please get in touch with us, because it is a little bit complex connecting to all these message brokers. It can be overwhelming, but more often than not, FME will be able to connect to that endpoint and pull the data in. So I think, we're going to start looking at some demos in a second, but the key thing we really want to take away from this webinar is with FME, you've probably been working with batch data for many years, and the same message holds true with stream processing data. What we want you to be able to do is get value out of your data streams without having to hire a programming team. And this is especially kind of poignant for high volume streams, because many of the open source tooling that's available, it's all about coding and programming. And while these frameworks can be very powerful, they're also quite complex to set up and to write code for. So with that, I think I'm going to pass you over to Mark, who's going to kind of walk you through an introduction to stream processing.
Awesome. Thanks, Stuart. Yeah, so let's first start talking about data streams and what they are. So data streams are usually defined as continuously generated data from multiple sources, and these sources are often simultaneously sending data in small sizes. So in the bottom in the graphic, you can see here we're comparing batch versus stream data, where batch is bounded, where there's a defined start and end to sets of data, whereas unbounded stream data, there is no beginning, there's no end, it just keeps arriving, and you need to be processing that in a different way than batch processing. So what are the common characteristics of data streams? The first is that the data records coming from the streams are typically small in size. These records are typically small blocks of JSON or XML, but when you sum up the data over a long period of time, the total data can be quite large. The second point is that data volumes can be extremely high. So what is data volume? It's the number of events happening at a given moment. And data streams can be low volume for certain periods, but they're high volume in nature. And if events are consistently low volume, you can often handle these with event processing, such as FME servers automations, rather than stream processing. And the third point is that the data distribution of these records can often be inconsistent with both quiet and busy periods. So stream volumes are often fluctuating, and because these are representing events happening in the real world, they usually don't happen at a constant rate. And the last point is that data can arrive out of sequence compared to when the event actually happened. So in an ideal world, an event is processed in real time, or in other words, as soon as it occurs. However, factors like network latency, hardware, processing software, and data sizes can affect the time between when an event occurs versus when it's actually processed. So what is stream processing? The full definition encompasses the collection, integration, and analysis of unbounded data to allow organizations to gather information and insights from massive data sets on a continuous basis. As mentioned, to enable this kind of processing, you need a new architectural pattern compared to batch processing. So streams generate a lot of data, but not everyone knows how to maximize the value of their stream data. And today we're going to be showing you how to do that with FME. So we're going to be jumping into our first demo here with a relatively simple scenario of filtering a high volume stream. So streams produce a lot of data, but that doesn't necessarily mean you want to store all of that data. Storing every record that comes from a stream can get very expensive, especially if you only intend to work with a specific portion of that data. And by filtering the data as it arrives and before you actually write it out to a database or a data warehouse, you save a ton on storage costs and time on cleaning up and filtering the data afterwards. So in this demo, the goal is that we want to reduce the data volumes from our stream in memory before we commit it to our disk storage. And the obstacle is that the stream data has to be treated differently compared to batch processing because it's continuous. And the solution is to create a workspace that continuously pulls in that data from our stream. We're going to filter it out and then write it to our data warehouse. And then to run the workspace continuously, we're going to publish it up to FME server and run it through our streams continuously. So now I'm just going to share my screen. All right, so here we are looking at just a basic beginning to connecting to a message broker. In our case, we are using Kafka. And I've already added a few things to this workspace just to showcase what the beginning of a stream processing workspace typically looks like. And you start off with a creator to kickstart the workspace, and then you add your message broker connector. Since we're using Kafka, we're just using the Kafka connector, but we support many different types of message brokers, as mentioned by Stuart. And in the parameters of the message broker connector, you'll see that here are all the parameters to actually connect to it. And the main thing that I want to be highlighting here is the receive behavior parameters. So you'll see that the mode right now is set in batch mode, but there is another option for stream mode. When the mode is set to batch, we'll be pulling in a set amount of data from our queue. In my case, I'm going to be pulling in 10,000 records, and then it's not going to pull in any more. But if I wanted to be running this continuously and constantly pulling in those messages from Kafka, then I want to change the mode to stream. But I'm setting it to batch mode now because this is really useful when you're actually building the workspace. So you can see the data as it's coming through by using feature caching in desktop, and it's really useful for just authoring and debugging. So I'm going to leave it on batch mode for now. And just to take a look at the messages that are coming through in the stream, this is our hosted Kafka message queue where we are reading vehicle fleet data. And this is just getting information about vehicles throughout the city of Vancouver. We're just getting the vehicle ID, the vehicle type and timestamps, and the point geometry of the location of that vehicle. And you can see that's in just a basic JSON format, and we're going to be parsing that in our workspace and then doing further processing. So I'll just run the Kafka connector first to pull in 10,000 records for our testing. And once those records are in, we will be able to check what they look like. As you can see here in the visual preview, there is the JSON payload in the value attribute, and we're going to be parsing this in the JSON flattener. And as mentioned and as seen in the queue that we just saw in real time just there in Confluent Cloud, the attributes that we're pulling in are the vehicle ID, the timestamp, the category, and the point geometry. So when setting that up, we're going to be extracting those attributes from the JSON into individual attributes or columns. So you can see that's what we've done here with our data. And now let's say I was only interested in vehicle types that are trucks, and we want to exclude sedans and SUVs. To do that, you simply add a tester. Another option is using the test filter if you want to be sending the data through many different ports more than just passed and failed. But in this case, it's just a very simple filter, and I just want to filter the vehicle type on trucks. What this is doing is that all the data that matches that particular attribute value, they're going to be passed, and everything else is going to go out the failed port. If we don't connect the failed port to anything, it's just going to be discarded in memory, and then it's not going to be written out to our database. But just to show that in action, when I run the tester, we're cutting our data almost in half. So we're going to be saving a lot on storage just by using this transformer alone. And then if I want to do some attribute management before actually running it into my database or data warehouse, I can add an attribute manager or one of our other nifty attribute management transformers. In my case, I just want to remove that information. I don't care to rename anything, but if I wanted to, I could do that as well. And then lastly, I can add a Postgres writer. And this will be writing to my Postgres database. So for the vehicle, or for the table name, I can call it vehicle truck fleet. I can leave the rest of the parameters as needed. I can create the table if needed and insert those records in. Then I'll just connect that to the attribute manager. So when I run this in stream mode, it's going to be just constantly writing those records into the database. But one of the key features of our database writers that you want to be paying attention to when it comes to stream mode is the advanced parameter for features per transaction. So right now I have it set to 1,000. So it's going to be committing those transactions at 1,000 records at a time. So depending on the volume of your stream, you want to be adjusting this value so that you're able to receive your data in a reasonable amount of time. So if I was only receiving, let's say, 10 records per second, it might take quite a while before I actually see those in the database. So I might want to lower that value. But in my case, I'm receiving about several hundred per second. So I think 1,000 features per transaction is fairly reasonable. So when I'm ready to run this in stream mode and deploy it up to FME server, then I just need to switch the receive mode to stream. And just to showcase what this looks like in desktop, I'm going to rerun the entire workspace. And it's going to open up that continuous connection to our Kafka connector and be pulling in tons of records at a time. And first, it's starting off by creating that table in Postgres. As you can see, when I was running this in stream mode in Workbench, it's not actually stopping the workspace. You can see up here, I can stop it whenever I want because it's just continuously running. But that is a little bit of a problem because if I close Workbench, it's going to stop the stream and it's going to stop the translation. So how do I maintain that constant connection? And the answer is deploying it on FME server or FME cloud. So that's what I'm going to do now. I'll just publish it up to my FME cloud instance. I'll put it into my stream processing repository. If I have any database connections that are in the workspace, I want to include those as well. Many of our stream connectors are deployed or shared as packages. And in my case, since the Kafka connector is coming as the Apache Kafka connector package, I want to make sure I'm uploading that to server as well. In my case, I actually have already uploaded that, so I don't need to include it, but I'll just include that in the publishing just for demonstration's sake. When it comes to registering services, it might get a little bit tricky with the data streaming service here. This actually is not for stream processing. This is for a completely different type of batch processing. So just without getting into too many details, when it comes to deploying a stream workspace, you just want to submit it as the job submitter because the job submitter is just running the job and that's all it's doing. So I'm publishing up to my FME cloud instance now and transferring the connector package and other necessary information along with the workspace. And once I have that set up, see, I just need to open that up right here. So here I am in my cloud instance. And when it comes to building my stream, then I just want to go into the menu where it says streams. People who have been using FME Server 2021, you may have come across this, but you may have not understood how to use it. And that's what we're going to show right now. So to build a stream, it's a really simple process. You just click build stream and give it a name. So in this case, I'll call it the truck filter stream. Give it a description if you wanted, and then just select the workspace that is running our stream processing workspace. So in my case, it's the discard based upon attributes. Any parameters that we need to configure will be allowed to be set up right here before actually creating the stream. Once it's all ready, I'll just click OK. And now my stream has been created, but it's not running yet because there's one last step that we need to do, which is assigning engines. So when FME server is running jobs, it needs to run on an engine, and you can have multiple engines on an FME server instance. And when you are running a workspace in stream mode, it's running it continuously. So that means it's going to be constantly using that engine. And that's what we want to allow you to manage in this stream, where you can actually assign and dedicate one or more engines to a stream. And that's what I'm doing here. I'm just going to select my engine 1. And the moment I assign that engine, it's going to allow the stream to now run on that engine continuously. And the job will start running in just a moment down here, and we will see it start. And it will be then pulling in those records from Kafka and writing to our database. As you can see, there's that job running right now on our engine 1. So now back to the slides. So the result of this demo is we showed a way to really quickly filter out a very high volume stream to reduce the amount of data that you're storing, because you only need the information that is related to a particular type, and you just want to save that and process that. So to do that, we set a connector to run in stream mode, and we were filtering not based on groups, but just based on an attribute. And then we set a commit interval on our writer to be writing to our Postgres database after a certain amount of records have been received and processed. And then also showcase the difference between batch mode and stream mode when it comes to debugging and building your workspaces. So now I'm going to pass it over to Stuart for the second demo.
Great, thank you, Matt. Yes, so that's a very interesting demo. So what we're going to do now is really build on Mark's demo. So Mark's demo, he just flowed all of the features through FME. So you can handle really high volumes filtering data, but we didn't do any analysis on the data. We didn't, break the data up into chunks and then start analyzing the data, taking averages or doing things that you're used to doing with batch data. So that's what we're really going to look at now. How do you do group-based stream processing in FME? So the answer to this is you use something called windowing. So I think this is the most interesting part of kind of stream processing. The concept around windowing and the mental model, it goes beyond FME. It's kind of a pattern used throughout the kind of stream processing world. And what windowing means is it means that you take the data stream and using time, you break the stream up into groups. So you can see here, we've got an example. We've got a sensor here, a temperature sensor. It's recording data, let's say, every few seconds. And maybe you want to take an average temperature over a 1 minute period and store that in a database. Or maybe you want to filter the data. So to do that, you need to group the data up into chunks. And so you do that using time. And in FME, we use a transformer called the time windower. And we'll have a look at that in a second. But the key thing here is it's just a different model, because somehow you need to split that stream up. And that's easy with batch data because you're reading everything into memory, and then you've got everything in memory. So then you can sort the data, you can filter it, you can do group by on kind of everything that's in memory, but you don't have that luxury of stream processing. So the other consideration when you're doing this stream processing and the analysis is, let's say you have you're logging the location of vehicles in Vancouver. That's what this demo is going to be all about. And obviously these vehicles, they're on the network. So in this example here, we've got kind of 3 timestamps. So let's say 3 vehicles. Now, some vehicles are going to say log at 12:01, and then 2 seconds later, that data is going to arrive into our infrastructure. Whereas some vehicles may have network connectivity issues, and that data may arrive 2 minutes later. So this example here, you see the red dot. This was actually logged at 12:03, so along the time along the bottom, but the data didn't it didn't arrive into kind of FME or into Kafka until around 1207. So we need to account for this kind of out of order stream data when we're doing processing. It's all very well that we're going to chop the data up, but we need to add some kind of buffering around these windows to make sure we allow for kind of this out of order stream data. And we'll look at that in a second. So here's the demo. So this is a little bit more complex than the last demo. What we're going to do is we're going to thin a high volume data stream of vehicle locations. But more than that, we're going to then use the geospatial capabilities of FME to snap those points to a road network before saving. And the obstacle here is volume. We've got around 9 million points an hour coming in on this stream. Each vehicle is reporting its location roughly every 5 seconds. So we want a really low, kind of performant, low latency way to thin this data. We also need to make sure that this data exactly snaps and aligns with the road network, so analysis can be done downstream. Yes, we could store this to a database and then do the cleaning, but why would you? We can do it in memory and FME kind of as the data's flowing in. So you'll see the workspace here we have in a second. The workspace connects to a Kafka endpoint as similar to Mark's demo. And then we're going to have a look at that time window transformer in collaboration with the kind of neighbor finder to do the snapping. So let me share my screen here. Okay, so here's the workspace. I'm actually going to set this running so you can see the data coming in. So we've got 2 branches to this workspace. The first up top, this is our road data for actually the whole of BC. So we're going to filter this road data and we're going to set the coordinate system on it. So that's quite standard. That's not a streaming data set. That's just, I think it's a file geodatabase. So we're just reading that in once, and then we're going to apply that data downstream in the neighbor finder as the candidate that we compare the stream points to. This second stream, this is where things get interesting. So this is our high volume stream of the vehicle locations. So you can see the velocity that we're dealing with here. And this transformer here is set to stream mode, just so you can kind of see it in action. We've got the JSON flattener here, as Mark showed in the previous example. Now this is where we start to use the time window and things get interesting. So what we've got here is I can't even remember, but tens of thousands of vehicles in the lower mainland, and each vehicle is reporting its location every 5 seconds. Now that's a lot of data to store in a data warehouse. But what we're going to do is, for this project, we really only need the accuracy every 30 seconds. So we're going to thin this data, and it might sound kind of minor, or instead of 5 seconds, we're going to thin it, and we only need 30 seconds, but it's a 600% decrease in data volumes by doing this thinning. So that could save you thousands of dollars a month in data storage. Now, if we look at the time window, we have a 30-second window here. So every 30 seconds, what's going to happen is the features coming into this transformer for each window are going to be given a window ID. So let's say between 8 o'clock and 8 o'clock and 30 seconds, all the features arriving then will get one window ID, and then between 8 o'clock and 30 seconds and 8 o'clock and 1 minute, they'll get the next window ID. And this is a crucial thing because now all of our features coming in, they're grouped. We have an ID on them that we can use downstream. And so we can sort the features based on the vehicle ID and the timestamp. And so now we know that all the features in this group, in this window, are nicely sorted. And now they're nicely sorted, we can sample and we can just get the last vehicle the last point for each vehicle in each window. So that's how we're doing the thinning here using the sampler. So now what we've got coming out of here, you can see the data reduction here. We've got nearly 250,000 points we've already read in while we're talking, and we've thinned that down to 50,000 points. Now, one more thing to show you with that time window. If you remember back to that out of sequence slide, so let's go back in the time window. You can use the time window so it just windows based on when the feature arrives to the transformer. but often you want to window on the event time. So when the actual event happened in the real world, in this case, we've got the timestamp the GPS logged. And if you select this data has timestamps and set that to yes, you get this tolerance settings here. So this is saying for each 30-second window, I'm going to keep that window open for 10 more seconds. And I'm going to let any features come in the prior window for 10 more seconds. And then once 40 seconds is up, that's when I'm going to flush the features through. So you're going to have to play around with this. Maybe that's too short, maybe that's too long. The way we can tell is by looking at this out of sequence port. So all the features coming out of the output port, they matched a window. They're in a window, they're good. These ones out of sequence, these ones came after a window had closed. They did not match an open window. So, you know, this is quite high, honestly. We've got 500,000 coming output and 260,000 out of sequence. So I might want to actually increase the tolerance slightly here. Okay, so that's the window, extremely powerful. Our data's now nicely tagged, it's grouped, it's been filtered. We've dramatically reduced our data volumes. Here's things where things get really powerful with FME. Now I'm going to create geometry out of every GPS point that's coming in because it's just text on the JSON. I'm going to reproject to the same coordinate system as the road data. And then I'm going to compare the GPS points to the road data and snap them based on a 5-meter tolerance. So now this data coming out of here, we know that these points are exactly sitting on top of the road network. So we can do network analysis downstream on top of the geodatabase. I'm just logging this out here, but I could write out to a data warehouse or Postgres or any format FME supports. Okay, so let's go back to the slides here. So the result here, well, we've reduced data volume by a factor of 6, and we've also snapped the data to the road network. So very, very powerful, all with less than 15 transformers. And the key things here, we're using that time windower with that ID to split the data up into windows so we can process it. And then we're using event time, so we're setting the tolerance and we're leveraging that out of sequence port. So hopefully that's given you a really good kind of insight and introduction into this different mental model that you need to kind of approach stream processing with. What we're going to do in the final demo, which Mark and I are going to kind of share, is we're going to look at, we're still going to do some windowing, but this time we're going to, instead of joining to a static data set that updates every, how often does a roads data set update for BC? Maybe once a year if we're lucky. We're going to join to stream data to another data set that's updating every second. So how do we do that? And what does that look like? This is another kind of really kind of powerful pattern. So again, Mark will give a more in-depth look at the demo in a second, but let's imagine we have a stream of vehicle locations come in, assets, it could be anything really. And what we want to do is we want to join to a data warehouse that contains some of the data. So that data warehouse is updating every second. And so what we need to do, each window is going to basically, each window is going to connect to that data warehouse. And it's going to refresh. So every window, let's say we have a 1-minute window, every 1 minute, we're going to go back out to the data warehouse, pull the new data in and include that in the analysis that we're going to do to kind of, here we're redistributing drivers downstream, but we're doing some buffering, but you can really do any analysis. So Mark's going to walk you through that kind of process now and what that looks like with the demo.
Awesome. Yeah, thanks, Stuart, for the intro. I'm just going to share my screen now. All right, so here in this next workspace, we're going to be starting off with a very familiar start to the workspace, as we've been seeing, where we're connecting to the Kafka message queue. For demonstration purposes, I'll set it to batch mode, and I'll just read in 1,000 records. And then we're going to be extracting our attributes with the JSON flattener. And then we're going to do some extra filtering with the tester, where we only want to be checking for a particular vehicle type. And what we're doing in this particular part of the workspace is that we're going to be getting our driver locations for a ride-hailing app. And these driver locations, they're constantly updating, they're moving all around Vancouver. And we also have our users. Our users are stored in a Google BigQuery table. And then that is what's going to be constantly being refreshed. And that's where we want to get that information about where our users are. We're going to want to see where the drivers are compared to our users. And if our drivers are not within, let's say, 1 kilometer from our users, we want to notify them to redistribute them so that they go back towards our users, so that they don't have to wait very long for a driver when they call for one. So we're going to start off by pulling in those records that we're interested in for our drivers, and just to get their locations. As we had seen in the previous demos and in this one as well, when stream data is coming in, it's usually non-spatial. And when you want to do spatial processing on it, you need to have those geometries. So that's where FME's power really comes in with our spatial transformers. And what we're doing here is that we're taking the geo attribute, which is in well-known text, and we're going to build those point geometries from it, set it to the correct coordinate system, and reproject it to a different coordinate system that is common with our second data set, so that we can do some spatial joins further down in the workspace. So when I run up to the reprojector, you're going to see in the visual preview in just a moment, here are the points, and they're now appearing in the city of Vancouver, and we're almost ready to do our spatial processing. Now, here is the second part of our workspace, where we're going to be doing the refresh of our users' locations. So what we're doing in the time windower is that we are windowing on 30-second intervals. So every 30 seconds, we want to be processing that particular snapshot's worth of data, where we want to get our drivers' locations in that 30 seconds, compare it to our users' locations in that moment, and then check those distances from each other. So what we're doing here, once again, is filtering out our driver location up here up top with the sorter and the sampler, just as Stuart had showcased. The reason why we're doing this is because more than one location may be reported within a 30-second window for a particular driver, but we're only interested in the most recent location of that driver. So we're just using that same sorter and sampler method, using the window and the vehicle to get the last N feature, which is the most recent location for that driver. And then you'll notice here that we have connected the window changed port from our time windower to our Google BigQuery connector. So the Google BigQuery connector, as a reminder, is the constantly refreshing locations of our users for the app. And we want to use the window changed output to flush and refresh that data for the user's locations, build those geometries, and create a 1 kilometer buffer around our users, and then do our spatial join in the spatial filter to see where our users are compared to our vehicles. So you'll see that we're just doing a very simple filter contains candidate. Our filters are the 1 kilometer buffers of our users, and the candidates are our drivers. And notice that we're also doing group processing, and we're grouping on the window ID. This is going back to the idea of processing those snapshots, those groups of data, so that we're only seeing what is going on within each 30-second window. One key thing to note about this transformer and certain other types of transformers is a filter type. Other transformers may have a different name for this particular parameter, but in my case, I've set it to filters first. And the reason why I'm doing filters first is because order matters in this workspace. So this is, once again, making you rethink how FME works. When you're setting filters first, you're telling FME to make sure that these filter features are received at the spatial filter before the driver's locations. So the reason why that's a requirement is because if you receive the driver's locations and they don't have anything to join on in that moment, they're just going to get rejected. So by setting filters first, we're guaranteeing that those driver's locations have something to join against the moment they arrive in the transformer and as they're processed. So now when I run the workspace, I'm just going to make sure I switch the Kafka connector back to stream mode. And when I rerun the workspace, we'll get to see how the window changed port is actually working with the time windower. So first, we're letting those features come through from our Kafka connector. Might take just a moment, but you'll see here that single feature came through the window changed port, indicating that a new window is open. And we've gathered 546 locations of users. And now we're going to be passing in the driver's locations into the top section of the workspace, where we're going to be filtering and thinning it out so that we only have those most recent locations in the 30 seconds. And after that processing has been completed, then we're going to be receiving that spatial join result. So you can see that just happened, and we have a second feature that came through the window change port to refresh the locations of our users. And based on the processing in the spatial filter, 9 of our drivers are not within 1 kilometer of a user. So then we have a logger, but however method you want to notify the drivers to redistribute, that's what you would have in replacement of this transformer. But yeah, I hope this gives a good overview of a relatively complex spatial processing scenario that incorporates stream data. And to bring it back to the slides. Oh, I guess I didn't cover this slide, but anyways, the result is that we are doing a real-time join between stream data and also refreshed data from a data warehouse to create dynamic geofences, because we had moving objects, and those were people, and we created and constantly refreshed those locations of our users so that we can get very up-to-date information about our drivers' locations. And we are utilizing the window changed port to make that functionality a reality. And we were constantly refreshing that data from Google BigQuery with those output features from the window changed port. And by using the buffer, that's where we had those dynamic geofences come in. So I think I'm going to pass it over to you now, Dale.
Thanks so much, Mark and Stuart. So I hope all of you have gotten a sense of how you can tame those boundless streams of data using FME technology and basically get to the value of what that data is without having to do lots of fighting with it. On a personal level, it's very gratifying for me to see how the technology that Don and I started off creating 28 plus years ago can be used to solve problems we never imagined. I don't even think they even existed when we began, but the architecture lends itself to solving these problems so nicely and so very well, thanks to the insights of people like Stuart and Mark. So hopefully you've learned some things there, learned about how FME processes data and how streams work in general and how you can harness them using FME. If you'd like to find out more, there's a number of different ways you can. We, of course, are always interested in chatting with you. There's live chat on our website. As Mark said at the beginning, you might even chat with him sometimes if you do that. Of course, you can email us at info@safe.com. You can grab the latest FME and get these workspaces. Elizabeth tells me they'll be mailed out to you right away. Shortly after this webinar ends, you'll get an email from us that will have links so you can get the the workspaces that were shown today and start to think about how they might be able to be applied to your own environments. If you really like this stuff and you don't have FME already, there's a bunch of ways you can engage with us. We do sell subscriptions, and especially if you're in local government, those are very attractive, but for enterprises, they are too. Lower upfront cost, you can have as much FME as you want. You can also buy individual licenses off of us, and that's what we've been doing for a long, long time, and many of you have done that. Or you can use the work of Stuart's labors for many years and use FME on the cloud. I should put Stuart on the spot. How long has FME Cloud been a thing up there, Stuart?
Oh, it's about 6 years now since our first customer.
Yes. So that's very tried and proven technology, and we're always looking at ways to do more on the cloud as well. And I won't even get into the latest ideas. We just held innovation days at SAFE last week where people can work on whatever they want, and there definitely were some things that have some implications to the cloud too. In terms of other resources, we got a few links here. When you get the slides, you can follow those. I don't know what our best practice is in Livestorm, if Elizabeth will chat these links out or not, but nonetheless, you can see that we've got tutorials related to this that Stuart and Mark have put together, and as well some videos and other materials if this is something of interest to you. If you are part of our community, and there's no reason not to be, you can join that by going to safe.com and then finding the community link. But nonetheless, if you're part of the community, you can grab a badge for today's webinar, and that's BACPM, BACPM gets you another badge. We also partner with Gartner to find out what you think about us. And so if you are able to send a review in, spend a bit of time there, please do. I think Elizabeth will chat out the link for that as well. And that'll be in the slides afterwards too. We do appreciate that. Lastly, our long-awaited conference is about to take place. I was getting some memory reminders in my apps. I'm thinking we're either at 5-year anniversary right now or within a few days from when we last held this. So we normally do this every 3 years. So this conference should have been in 2020, but in fact, it is going to be this summer near the end in August. You can come on up to Vancouver, and I've had a chance to see the user talks that have been submitted, and they are absolutely fantastic. So, so you won't want to miss those. There's so many great talks on deck for us, and it should be just a wonderful time, and also a chance for all of us at SAFE to meet all of you and learn from you. We definitely have missed that over this drought, and man, oh man, it's been far too long since 2017 when we were all together. Yeah, and Elizabeth is always busy together with her team plotting out new webinars. I think there's some interesting ones coming up, and you can also look at some of our greatest hits in the archive. I know that we just did one, was it even last week or the week before, talking about data wrangling. That was one that the audience actually seemed to really like, and it was fun to explore how FME can be used for basically solving ad hoc data problems and putting data in its place, so to speak. So with that, we'll go to questions and answers. And I have not seen anything flying by in the questions panel. I haven't had a chance to look, so I don't know sure if Holly's here to chime in. But Elizabeth, what do we do next in this new platform?
Yeah, so we can just take a look through the questions panel there. It looks like the few that have come in so far, Stuart's gotten to, but I'm not sure, Stuart, if you're wanting to speak to any of those in more detail here.
Yeah, there's a few great questions actually. I mean, people can see, I think, if they click on the questions tab, but one of the questions is like how much engine is streaming using? So if you create, like Mark created a stream on FME server, he assigned an engine to it. So what does that mean? Well, what it means is that engine, it's obviously running all the time, connecting to that endpoint. So that engine it can't be used for anything else. But the good thing is with the new dynamic engines, is that what they're called now? I lose track, but yeah, dynamic engines. So basically, you buy credits, and then when the engine's running, it uses up some of the credit time. So with this model, you'll only pay when data comes in from the stream. So when the stream's really busy, you'll be draining CPU credits. But if the stream's quiet overnight or during a period, then the workspace is just sat there not doing anything, so you won't drain the credits. So there are flexibility there. You don't have to kind of, oh, I've only got 2 engines and I'm going to use one of them for a stream.
So Stuart, I feel like Crazy Eddie from the furniture store. Our prices are insane. Are you telling me that even though the engine is actually arguably running, it's sitting there, it's dedicated, it's connected to a stream, but if nothing is coming, if all the vehicles are parked, there's no CPU being used, we're sitting there waiting, we don't charge people anything for that in the dynamic engine model? Is that what I'm hearing, Stuart? Is that how crazy we are?
You know what? I think it might be like parking your Tesla at the airport. It's still tiny little bit of drain, in the background, because there is a little bit, but it's very, very minimal.
Our prices are insane, folks.
Yeah. And you can scale engines as well, actually. So that's something we didn't touch on. But if that stream is really high, you can keep adding more and more engines. So like with the filtering with Mark, that's a scalable process because you're not doing group by. So you can just keep adding engines to kind of make sure that nothing's backing up there at the endpoint.
I also can think that our developer team is really costing us money, Stuart, because they're making FME more and more efficient all the time and using less CPU to solve problems. And so every time they're doing that, these jobs get cheaper to run. We're crazy, aren't we?
That might keep me up at night if the data volumes weren't increasing by 10 every 2 years.
Yeah, that's true.
Yeah.
Yes, exactly. Great. So any other questions we wanted to highlight here?
Have you got any there you want to pull out, Mark?
Let's see. Well, there was that one about the snapping vehicle locations to the road network, and the road network being updated. I noticed you added a note about that, but I guess one thing I wanted to point out about your demo versus mine was that yours was pulling in a static data set. So once it's pulled in, then it's just constantly being used in the neighbor finder for those comparisons with the stream data. Whereas with that last demonstration, we were using the window change port to constantly refresh data. And in our case, we were using a Google BigQuery connector, but you could use it with another transformer like the feature reader, and then you can be constantly refreshing a different data set. Was there anything else you wanted to add about that question, Stuart?
No, I think that's great. I mean, when you start that stream on FME server, it's running forever in inverted commas, but obviously it's not probably going to run for a year. Like the engine's going to restart. There'll be downtime of a few milliseconds. And at that point, then it gets reread into memory. So if your data set is updating monthly or annually, I wouldn't worry about it. But if it's updating like every hour or something like that, then you need to think about your workflows.
Mm-hmm.
So I just wonder, we only got a couple minutes left, but Stephen Smith's question about the time windower is interesting, where the question is, if the windower is set for a 1 minute window and you give a 5 minute leeway, so in other words, the leeway is much larger than the window size. Is that a-okay, Stuart? Or do you have to have I can't remember what the rules were about the interaction between the forgiveness and the window size.
Yeah, I don't think that's going to work. Your tolerance needs to be less than
okay.
the window size, otherwise you get strange behavior.
Yes.
But yeah, it's an interesting thing to play around with. Kind of, obviously, you increase the window size, you increase the kind of latency because it's going to sit there for a few more minutes.
Yes.
But yeah, if you had the tolerance, we let you do it, but it would have some strange behavior, I think.
Here's a wild one for you, Stuart, because I have to think through if I would believe this might work. But you could, if you knew you had 5 minute wackiness and you wanted to window at every minute, you could do a time windower with a 5 minute window and 5 minute forgiveness. That would get you into 5 minute groups that would come out of that. And then you could sort those. And now they're going to be in order. And then you could put another windower after that that's set for 1 minute, and you don't need any latency or any delay at all. So in other words, this has not been tried. This is, kind of all on your own. But we might want to do an experiment with that, but I think that would work. So again, it's like Lego. You can put these pieces together and experiment, but I kind of think that would work. And you could put order to a nasty data stream with a couple of time windowers back to back and a sorter in the middle to put order to things.
Yeah.
Anybody on the call? Bo has asked about KSQL DB. That's a new format from my perspective, and I'm really curious. We'll definitely get this on our list, Bo, but if you could tell us anything more in the chat, or maybe we'll be in touch with you afterwards about the use cases for that, or where that thing lives. But I don't know, Stuart, Mark, Holly, have any of you heard of KSQL?
I have not, actually.
I think it sits on top of Kafka streams, so it's a kind of a Kafka extension. I haven't run into a customer asking for it. I wonder if it has like a JDBC interface or something like that, because I think it's Java. So yeah, we'll have a look at that.
Yes, thanks, Bo, for letting us know about that. And Tony asks a great one, and this I know is something that both Mark and Stuart have talked to me about. Are there any, like, if you want to just play with this and you don't happen to have your own stream of, let's imagine car locations in Vancouver, like, I know you guys, I've heard you mumble about something about transit having a feed, but what else, or what, if anything, is there out there that can be tapped into and played with?
Yeah, transit does have a feed, like so. Is it City of Vancouver or BC Transit, right? The problem is with high volume streams is they cost a lot of money. They cost a lot of money to run and maintain. So I haven't actually found a public, really high volume stream for consumption. If anyone can chat any of that, would be fantastic. But everything you saw in our demos is all simulated, and like, you know, the BC Transit one has a feed of the buses in Vancouver, but it's not that high volume, is it, Mark? I mean, there's what?
Yeah, and I think I haven't tried connecting to that through a stream. Like, I know we've connected to it like as an API. I'm just like using an HTTP caller to get the information. In terms of like just thinking about a stream that you could set up on your own, I know that Confluent Cloud does have like a trial period, which you could use. And in our Kafka connector, we do have the ability to both receive and send messages. So you could set up a workspace to like load up a trial queue full of messages and then just start working with it in another workspace where you're pulling that data back down from the queue. So I think that is one option.
Yeah, nice. Yeah, BigQuery, Google BigQuery has some sample geospatial data sets that are huge, like the taxi locations for every taxi in New York for like 5 years or something. So they're all in a massive database, but you'd have to simulate them coming out into like Confluent Cloud to build that kind of demo.
Ali mentioned that the city of Vancouver does have sensors that are collecting traffic counts and going into a database, but I don't think that's available publicly. But that's a good use case that's happening right here with one of our own customers, but not available publicly, I don't think.
All right. And with that, if you guys do have any questions that still come to mind, we'll definitely leave things running for a few more moments here this morning, and we'll answer those on the back end for a few moments. And just a big thank you for everyone who attended this morning and to our team of panelists here this morning. We'll drop a link in the chat now to download FME 2022 if you have not already, and to let us know what you thought of the webinar today. We have a form there to fill out.
I like all these thumbs up.
Yes. I did see over in the chat, some of the folks were giving us suggestions for stream data sources that we might look. Thanks, Herman and Renzo. We'll take a peek at those, and any of you as well might want to. But I think it's time that I will say goodbye. Thanks, everybody.
All right. Thanks, everyone.
Thanks
everyone.
Bye-bye.
Bye.
Take care.
Bye, guys.